Welcome to this interesting and short topic, electricity. Well, it's not short, it's just that it is too interesting such that you are going to perceive it to be short. So we're going to start my right. So the way this topic is going to be delivered, we're going to start with an introduction which is going to give us an idea into the two types of electricity. Then we are going to take a look at one type of electricity called static electricity. Then we'll take a look at another type of electricity called current electricity. Then we'll end this topic with practical electricity, which is electricity in our day-to-day lives, which means electricity in our homes. So this video is just going to be on static electricity, the next video current electricity, and the last video practical electricity. So when an atom loses or gains electrons, it becomes charged. Remember, in chemistry we learned that atoms lose or gain charges, lose or gain electrons. When they lose or gain, we say that they are charged. It can be positively charged or negatively charged. So with that truth, the material the atom is part of is also said to be charged. So if we have got this Chitenge material that has its atoms are charged, that material is also said to be charged. So there are two types of charges. The first is stored charge which is not moving, which is stored, waiting for something. Then the second kind of charge is moving charge. Okay, so this video is going to be based on stored charge, which is also called static charge or static electricity. Then the next video is going to be based on moving charge, which is called current charge or current electricity. So I'm going to just share with you three situations where we experience static charge. The first is a situation where you have covered yourself in a sweater, then you have exposed yourself to, let's say, maybe it's a cold day. Then at night, sometimes when you are about to remove the sweater, you can hear some sparks or see some sparks. Those are as a result of charge. So it means that in the environment you're exposed to, your sweater became charged. So as you are moving it, it is somehow discharging. Okay, another situation is lightening, which you are going to explore in details soon. The other situation is when you are stepping on a carpet, then you touch a doorknob. So you're going to experience some charge, some electricity. So that is as a result of charge which is stored, static electricity. So what causes an object to be charged? In chemistry, we talked about stability, but in physics, we are looking at it on the materials perspective. Physics is about materials. So on materials perspective, what causes an object to be charged is rubbing. Okay, when two different substances are rubbed, they become charged. So rubbing causes electrons to be lost by one material and to be gained by another material, resulting in both of the materials becoming charged. Essentially, a material is neutral. What does that mean? It means the fundamental particles are balanced. The fundamental particles, I'm talking about electrons and protons. So if a material has equal number of electrons and equal number of protons, that material is said to be neutral, because protons are positive and electrons are negative, so they cancel out each other. It's like you have two protons, it means you have positive 2, you have a charge of positive 2, and you have two electrons, you have a charge of negative 2. So when you add them, you're going to get 0. So such a material is said to be neutral. But let's say we've got a polyethylene here and Hu. So if we rub Hu and polyethylene, then the electrons in Hu are going to be transferred to polyethylene. Okay, so this is what has been observed. When you rub Hu and polyethylene, the negative electrons in Hu are going to be transferred to polyethylene. Because of that, Hu is going to have a reduction in the negativity. Therefore, it's going to be positively charged. Well, polyethylene has gained more electrons, so it's going to be negatively charged because it has gained some negativity, so it's going to be negatively charged. So this is how the science of charge happens. So there are two laws of charge. The first is like charges repel. The second is unlike charges attract. So what these two laws mean is, the first law is a situation like this. So it says if you take two particles that are that have the same charge, you try to push them closer, they are going to push each other away. So we take positive ones, we push them together, they are going to push each other away. We get negative ones, you push them together, they're going to push each other away. Then the second law is if you get opposite charges, they are going to attract. For those with a bad memory like me, the way to see it is opposite sex attract female. Opposite sex attract. That's boys and girls are attracted to each other. Boys and boys are not attracted to each other, or they repel to each other. Like they say, women don't help each other. So maybe here it might apply, but that's just a joke. With that being said, let's continue. Next, we looked at induced charge. When charged particles are placed near uncharged particles, which are neutral particles, of course, charge can be induced into the uncharged particles, making them charged. You get something that is charged, you put it close to something that is not charged, charge can be induced into the uncharged particles. This is called induced charge. So let's picture this situation where we have this neutral, material substance, where the number of positive particles and the number of negative particles are in balance. Then we get another material which is charged. This one is negatively charged. So if we push this close to this one, what's going to happen is the charges in here are going to rearrange themselves such that those which are opposite of these should be here, so that opposite charges attract, and those which are like this should be away, like this. So the positive ones are going to be here, opposite attract, then the negative ones are going to be away from the touching surfaces. So this is how induction of charge happens. Finally, we explain the lightening, how it happens. So clouds are the ones that bring about lightening. How? When air is flowing, air rubs on the surface of the cloud. Because of that rubbing, the cloud becomes charged. So if there is another cloud after that, another cloud near that charged cloud, and that cloud, the other cloud, is not charged, charge might try to flow from the charged cloud to the uncharged, using the process of induction, of course. Therefore, the flow of charge is what we observe as lightening. Another situation is when the surrounding air is not charged. So charge might try to flow from the cloud which is charged to the surrounding air, and that is what we observe as lightening. So this is how lightening comes about. It is as a result of static electricity. And this marks the end of this very beautiful topic. Actually, it's not the end of this topic, but the end of this part of the topic. So the next we're going to look at current electricity that is moving, not one that is just stored somewhere. Happy solving.